Okay, so let's go through this question. We have this model of a structure in the shape of a square base pyramid, right? Has a scale of 1:100. Then after that, they say, oh, the diagram shows one of the lateral face. So apparently the diagram is here, right? Then apparently this is 2x. Then this is the height x plus 5. So they say, okay, write down an expression in terms of x for the total surface area of the model. Okay, so we got 4 triangle and 1 square. So let's determine the square first. So the area of the square, right, is 2x multiplied by 2x. So this will give you 4x square. So that's the first part. Okay, then you determine the triangle. So triangle is half times base times height. So half, so this is one of it. So half times base multiplied by height. So definitely, right, you will get something like x plus 5. But this is only one triangle. We got 4. 1, 2, 3, and 4. So you times 4. So the total surface area, you times 4, right? So this will give you about 4x x plus 5 bracket. So you just need to add up. So for example, right, so the total surface area will be 4x squared plus 4x x plus 5. Then you just manipulate a bit or simplify a bit, right? So this will give you 4x squared plus 4x squared plus 20x, which in turn the final result will be 8x squared plus 20x. So this is the first part. Okay, then let's take a look at the part 2, the forming the equation, right? Okay, so we are asked to form an equation such that the total surface area of the model is 50. Formulate the equation. So we are asked to determine, final equation, I must get something like this, equal to 0. Okay, so how do we do that? Very simple. First, you equate this thing to 50, because they say that the area is 50, so means 8x squared plus 20x equal to 50. Then you move the 50 to the left hand side, because you notice one thing is that the right hand side, right, is 0. Means that this part also must make it to 0 by moving this to the left hand side. So 8x squared plus 20x minus 50 equal to 0. Then you divide by 2 short. Divide by 2, right? So it's 4x squared plus 10x minus 25 equal to 0. So that's for part B. As long as you are able to show and reduce the expression that is given, right, you'll be given a credit. Okay, part 3. You are asked to solve the equation. So to solve equation, to keep things simple, you can factorize, but sometimes you might not be able to factorize. So what we can do, right, is actually to use the formula. So for example, x is equal to negative b plus minus square root b squared minus 4ac over 2a. So let's determine the ABC, right? A is equal to 4, b is equal to 10, c is equal to negative 25. So you must take the sign together. So for example, right, 4, then b is 10. Okay, and c is negative 25. So you just sub in, you will get the answer. So x is equal to negative 10 plus minus b squared, right? So it's 10 square minus 4. A is 4. C, right, over 2a. So 2a is 2 times 4. So this will give you some number. Negative 10 plus minus. So this is 100 plus 100 plus 400 over 8. Let's determine this together. Square root 500. So it's about this part by itself, right? The square root by itself is equal to 22.4, give or take. Then you will get two answers. One is negative 10 plus 22.4 over 8. Okay, so you'll get something like 1.55. The next one is negative 10 minus 22.4, right, divided by 8. So it's about negative 4.05. So you got two answers. Okay, so for IV, explain why one of the solution, meaning why one of it 1.55 or negative 4.05 must be rejected as the length of BC. Because you look at the length of BC, apparently right, length of BC is 2x. So this is 2x. So if let's just say I sub in, this is x equal to 1.55, the other is x equal to negative 4.05. So I sub inside, you get a negative length, which is not allowed. So you just need to explain in this manner. So for example, 2x is negative, hence your x is equal to negative 4.05 is rejected. Okay, so let's talk about the last part. Find the actual floor area, right, in terms of meter square that the commemorative structure actually occupy. So we know, this is 1.55, but this is just the model. Because remember, right, they already tell us that, the model, this is the model, this is the real size one. You must times 100 at the end of the day. So first, let's talk about this. Okay, so my x is equal to 1.55, okay, 1.55. So, wait, don't need, actually don't need, okay. So because we already know the area of the structure is 50 cm square. So this is a model, so definitely the scale is 1:100. But don't forget, this one is the length is to length. Meaning this is the length of the model, this is the length of the real thing. You must square both sides. So square both sides. So this is 1:100, 100. So this will be the area of the model. This will be the area of the real thing. So you simply just use 50, because this is the model, times 10,000. 1, 2, 3. So this will give you 500 with 3 behind. So this will be cm square. But they want in terms of meter square. So you need to divide. So need to divide by 100. So this will give you 50 meter square. So that's how we do. Of course, to keep for the conversion of cm square to meter square, you can use another method. For example, the method that I teach you. So it's 500,000. You simply just put, maybe what times what will give you 500,000. So this will be 100,000 centimeter. This will be maybe 5 centimeter. So you times together, right, the area will be equal to 500,000. So simply just change 100,000 centimeter to meter. So you divide by 100. So this will give you 1,000 meter. 5 centimeter divided by 100, 0.05 meter. Simply just use this, multiply by this, right? You'll get the answer. You will get definitely the same answer. So the area in terms of meter square, right? So it's 1,000 times 0.05. So it's about 50 meter square. So that is how we actually do this question.